Wormholes, also known as Einstein-Rosen bridges, are hypothetical objects that have captured the imagination of science fiction writers and physicists alike. The concept of wormholes was first introduced by the physicist John Wheeler in 1957, but it was not until the work of Albert Einstein and Nathan Rosen in the 1930s that the idea of a traversable wormhole was explored in detail. In this theory, we will explore the concept of wormholes, their properties, and their potential uses. The basics of wormholes. A wormhole is a theoretical tunnel that connects two different points in space-time. It is essentially a shortcut through the fabric of space-time that allows matter and energy to travel between two distant points instantaneously. Wormholes are predicted by the equations of general relativity, the same theory that describes the bending of light around massive objects like black holes. Wormholes are formed when the fabric of space-time is warped by the presence of massive objects like stars and black holes. In general relativity, gravity is described as the curvature of space-time, and massive objects create a curvature that can be thought of as a dent in the fabric of space-time. A wormhole is essentially a tunnel that connects two dents in space-time, allowing matter and energy to travel between them. Properties of wormholes. Wormholes have a number of interesting properties that make them intriguing objects of study. One of the most fascinating properties of wormholes is that they are not bound by the speed of light. Since they provide a shortcut through space-time, it is possible to travel from one end of a wormhole to the other faster than the speed of light. This raises some interesting questions about the nature of causality and the possibility of time travel. Another property of wormholes is that they require exotic matter to remain stable. Exotic matter is a hypothetical form of matter that has negative energy density, which means that it has less energy than a vacuum. This negative energy density is required to keep the wormhole open and prevent it from collapsing in on itself. The existence of exotic matter is still a matter of speculation, and there is currently no experimental evidence to support its existence. Potential uses of wormholes. The potential uses of wormholes are numerous and varied. One of the most exciting possibilities is that they could be used as a means of travel between distant parts of the universe. Since they provide a shortcut through space-time, it would be possible to travel vast distances in a fraction of the time it would take using conventional means of space travel. Wormholes could also be used as a means of communication between distant points in space. By sending a signal through a wormhole, it would be possible to communicate with other civilizations on the far side of the universe in real time. This would revolutionize our understanding of the universe and open up new avenues for scientific exploration. Finally, wormholes could be used to explore the mysteries of black holes. Black holes are some of the most enigmatic objects in the universe, and we still know very little about them. By studying the properties of wormholes, it may be possible to gain new insights into the nature of black holes and the fundamental nature of the universe itself. Conclusion. In conclusion, wormholes are fascinating objects that have captured the imagination of scientists and science fiction writers alike. While they remain a purely theoretical concept at this point, they hold the potential to revolutionize our understanding of the universe and open up new avenues for scientific exploration. The study of wormholes is still in its infancy, and there is much that we do not yet understand about these intriguing objects. Nonetheless, the potential uses of wormholes are vast and varied, and they hold the promise of unlocking some of the greatest mysteries of the universe.